Nuclear energy is possibly one of the most dangerous things on Earth. It's killed hundreds, caused deformities in future generations, and ruined landscapes. So how surprising is it to learn that it can also be used as a relatively clean alternative to fossil fuels? Yep, we can create energy to power your lamps from the same things that atomic bombs are made out of. And it's happening right now, in tons of different countries globally. So how do we go from making what could possibly be a weapon into usable energy? The answer is nuclear fission. Nuclear fission is when an atom is split either by collision or spontaneously and releases energy. But how do we get an atom to split? The easiest way to do so is by using uranium-235, or U-235. This atom already decays naturally, occasionally throwing off alpha particles, 2 neutrons and 2 protons bound together. However, when a free neutron is fired into uranium-235, the atom absorbs the neutron, becomes unstable, and then splits. This splitting is where the energy is released. Doing this not only releases energy, but also a large amount of heat and gamma radiation. All of this has to happen in a controlled manner, of course, and this is where the nuclear power plant comes in. A nuclear power plant has many parts in it that makes, harnesses, and controls the nuclear power. The first step in this process is making the uranium-235 into individual rods. These are called fuel rods and are sorted into bundles that are submerged into a pool of water. In this water is where those rods would usually overheat and melt. However, to prevent this overheating, other rods, named control rods, are put into the same pool as the uranium. These rods are made of materials that absorb neutrons. The rods of uranium are now extremely hot and thus produce steam, which turns a turbine that generates the power. Most other parts of the power plant have to do with the dealing of radiation and all the other harmful things that come with the nuclear power.
Nuclear fission is becoming more and more popular throughout the world as the prices of petroleum skyrocket and people are looking for a new form of alternate energy. For many countries, a form of nuclear energy could be the solution. Nuclear fission is best used in the countryside and more rural areas as to not greatly affect the human health of said region. It could definitely be used nationally in China because most of the country's population is in its cities and there is a great deal of space that is not greatly inhabited. A lot of energy is necessary to keep these cities going. China is one of the largest users of fossil fuels, and a stable fuel that is not in immediate danger of running out is sorely needed in order to keep the country's vast export business and large population in check. Nuclear fission is a great way to gain a lot of energy quickly, and if you have the money to build one, which is between 10 and 12 billion US dollars, then you would be able to generate 1,500 to 1,600 megawatts of energy. The operating cost of a nuclear power plant is $0.0186 per kilowatt hour. This will eventually measure out to a positive output which is necessary for any country's electrical needs.
Of course, no environmental project would be complete without analyzing the environmental impacts. Nuclear power can and will have a big effect on the environment, both good and bad. First, we'll focus on the bad costs of nuclear energy. In reality, nuclear power plants are much better on the environment, assuming no catastrophic event happens. This is because the power purely relies on steam moving turbines, and steam is harmless to the environment. There are no fossil fuels being burned in the process of nuclear energy. One problem lies in the high-level waste, or simply the used-up reactants that make the steam. On average, one nuclear power plant produces 20 to 30 tons of this high-level waste with no practical way to dispose of it. Suggestions have been made to bury it extremely deep or send it out into space, but no suggestions have been implemented yet. Other wastes include gases that are released into the environment that contain a very small amount of radioactivity. The total amount is extremely small, less than 0.1% as radioactive than that a normal person would receive living at sea level per year. The main problem people have with nuclear power plants is the chance of a nuclear meltdown. While these events are rare, if they do happen, the impacts are catastrophic on the environment and the people living in the surrounding area. This is the main reason why people, especially those living in the close proximity to one of those power plants, don't necessarily like the idea of a huge power plant that can melt at any time in their backyard.
Nuclear fission may have some negative environmental aspects, But once built, a nuclear reactor will generate much greater funds for the company than other factories run on fossil fuels, such as coal, natural gas, and petroleum. For countries with a lot of money to spend on energy, the technology to build a nuclear reactor, and have large populations, nuclear energy is something good to look into. Once the plants have been built, the cost decreases tremendously as only uranium and plutonium are left to obtain. Uranium, however, cannot be considered a truly renewable resource. It is made by a natural process and there is only a certain amount of it left on the globe. However, because uranium was only used very recently as an energy source, there is only a very small percentage of it that has been used. A nuclear power plant can provide immense power at an effective cost after the plant has been built and uranium and plutonium are already obtained. Nuclear fission is currently used in 31 different countries as of 2012 around the globe, with over 430 commercial power plants. France, USA, Russia, and Japan all rank highly on the amount of nuclear energy produced. These 31 countries all have profitable nuclear power plants. Each country that has opted for nuclear energy has gotten favorable results. Economically, it makes sense to use nuclear energy because even though it may cost a lot of money to first build the plant itself, in the long term, countries worldwide have seen favorable results and profit margins.